Hi, today we will discuss about units and physical quantities. At the end of this video, you would be able to know the 7 fundamental physical quantities of physics and the units we use to measure them, distinguish the types of physical quantities, and how to keep track of significant figures in calculation. But before digging into the topic, let's know first what is physics. Physics is a study of matter, forces, energy, motion, and the way how we relate each other. It aims to study the nature at its most fundamental level. It encompasses the study of the universe from the largest galaxies to the smallest subatomic particles. Just like any other branches of science, physics is based on experimental observations and quantitative measurements. Like we do experiments, measure, gather data, analyze, and etc. But what particular thing are we measuring and observing? This is what we call as physical quantity. It is a physical property of a phenomenon, body, or substance that can be quantified by measurement, or a quantity that can be measured by an instrument. Examples of this are mass, height, dimensions, speed, force, and many other. It can be categorized as fundamental or derived physical quantity. When we say fundamental, it's base units. It can only be measured using an instrument. On the other hand, when we say derived physical quantity, it can be both measured by an instrument and combinations of the base units. For example, mass, fundamental physical quantity. Of course, you need a weighing scale in order to get your mass. Height, fundamental physical quantity. You need a measuring tool to get your height. What if volume? So that would be a derived physical quantity. Even speed and force are derived physical quantities. Take note that there are actually only 7 fundamental physical quantities, and the rest are derived, which will be discussed later. The other category is simply scalar or vector quantities. This will be discussed in the next videos. Note that being quantitative in physics requires measurements. What do I mean? For example, I have here Monkey D. Luffy, and I want to know how tall he is and what's his mass. Of course, the answers would be 1.74 meters and 64 kilograms. So take note that in describing physical quantities, both numbers and units are necessary. What if I have here a book of thickness 10? Well, note that 10 itself has no physical meaning at all. So again, I repeat, both numbers and units are necessary for any meaningful quantities. Note that to make accurate measurements, we need units of measurements that does not change and can be duplicated by observers in various locations. For example, a kid having a height of 115 centimeters measured in the Philippines. If I'm going to take this child to another place in the world, of course, our measurements must be the same even if the location changes. So scientists formulated standard unit systems that does not change. And one of this is what we call as the SI system or the international system. By the way, this is the French term. These are the 7 fundamental physical quantities that I've mentioned earlier, wherein length is measured in meters, mass in kilograms, time in second, electric current in ampere, temperature in Kelvin, the amount of light in candela, and the amount of substance in mole. Out of these 7, these 3 here are most likely used in physics. So take note that these are the 7 fundamental physical quantities. The rest are derived physical quantities, and these are the following examples for that. And actually, there are too many to mention. Aside from the SI unit system, we also have what we call as English system, in which length is measured in foot, mass is measured in pound, and time in second. We also have CGS system, wherein length is measured in cm, mass in gram, and time in second. SI unit can be converted to other unit system using these conversion factors here. So kindly familiarize these things. Reminders: when converting from one unit system to another, always be sure you're talking about the same quantity of phenomenon. For example, I am converting seconds to years. Of course, it is possible because both of them are units of time. But if I have here meter squared converted to cubic centimeter, well, that would be impossible. Since meter square is a unit of area and cubic centimeter is a unit of volume. These are also the prefixes for the SI unit system, so kindly familiarize this too. Also, in measuring physical quantities, uncertainties are always present. It means to say error. It indicates the difference from the measured value and the standard or true value. The equation for that one will be standard minus experimental enclosed in an absolute divided by standard value times 100. Take note that a maximum error of 10% is acceptable. When we say accuracy of the measurement, it indicates how close is the measured to the standard value. For example, the length of a stick is measured as 58.96 with an uncertainty of 0.02 meter, meaning to say the true value is between 58.94 and 58.98. How did they calculate it? 58.96 minus the uncertainty, the result would be this one. 58.96 plus the uncertainty, the answer would be this one. It can also be written as of this form. The difference between precision and accuracy. When we say accuracy, this would tell you how close a measured value to the standard value, while precision would tell you how close two or more measurements agree with each other, or repeatability or reproducibility of the data. Here's the analogy. Have you tried playing dart or archery? The goal or the theoretical value will be the center or the bullseye, while the dots will be the arrows thrown on the board. So if you'll notice for the case 1, the dots are very scattered from each other, and at the same time it's too far from the center. So you could able to say that it has low accuracy and low precision. Next, case 2. If you'll notice, all the points are centered into one location, and it's too far from the bullseye. So meaning to say, it has low accuracy, but it could repeat itself here into one point. So we could able to say that it has high precision. Next, for case 3, if you'll notice, it could hit to at least 4 to the center, but it could not repeat itself. So you could able to say that it has high accuracy and low precision. And lastly, the last case, it could repeat itself at the center, so meaning to say it has high accuracy and high precision. So take note also that sometimes uncertainties is indicated by the number of significant figures. So there are rules in determining them. Number 1, all non-zero digits are significants. So meaning to say from 1 to 9, they are significant. Example, 1894. There are 4 significant figures. Next, this has 1, 2, 3 significant figures. Another one, you'll have 1, 2, 3, 4, yes, 5 significant figures. Here's rule number 2. Zeros appearing between non-zero digits are significant. So zeros appearing between non-digits are significant. So here we have 3. This one will have 1, 2, 3, 4, 5, 6 significant figures. How about this one? You'll have 7. Rule number 3. Zeros appearing before non-zero digits are significant. So you'll have here, for example, you'll have 3 significant figures. Next, another one, you'll have Yes, one significant figure. This one has, yes, three significant figures. While rule number 4 would state that zeros at the end of a number and to the right of a decimal point are significant. So again, at zeros at the end of a number and to the right of a decimal point, they are significant. For example, here, you'll have four significant figures. How about this one? You'll have 1, 2, 3, 4, 5, 6. You'll have six significant figures. How about this one? You'll have also six numbers of significant figures. And lastly, zeros at the end of a number without a decimal point may or may not be significant. So for example, there are two answers here. Might be two or four significant figures. So there are also rules in operations with significant figures. For addition and subtraction, you'll have the number of the decimal places in the results should be the same as the least number of decimal places in any of the numbers being added or subtracted. So sa Bisaya pa class, for example, if I'm going to add this 3, so taas kayo ang answer. So, ang tendency, ang rule kay ang number of decimal places sa result. So, 14 na daan, point. So, yung giingon, ang number of decimal places in the result should be the same as the least number of decimal places in any of the numbers being added. So, kinsa ang naay pinakagamay o significant figure after the decimal point. So, here, kani after the decimal point, this has 2, kani kay 1, kani kay 1, 2, 3, 4 after the decimal point. So, ang pinakagamay og decimal significant figures after the decimal place is this 1. So, imo ang answer kay 14.7 meters. Another example here. I have this one, the add gihapon. So, the answer would be, the least number of significant figure is this one. This has 2 after the decimal point. Again, I repeat, after the decimal point. So the answer would be 13.21 feet. Why 21? The adjacent side, ang tapad nga side sa 0 kay 7. So mag-round off ka. So mahimong 13.21 feet. Next, for multiplication and division, the number of significant figures in the result is the same as the number of significant figures in the input number that has the fewest. So again, I repeat in Bisaya, the number of significant figures nga nasa result kay same daw sa naay pinakagamay og number of significant figures nga imong gi-multiply or gi-divide. So here, take note what's the difference between the two. Kani siya kay ang total number, ang pinakagamay og significant figure. Kani siya kay ang pinakagamay after the decimal point. So for example, multiplying 11.63 cm to 5.74 cm. So the answer would be this one. So this has four significant figures, while this one has three. Okay, so your answer must be 66.8. Okay, 7, the adjacent side is 5, so plus 1. Next, we'll have 16.9 meters square times 5.740 meters square, so the answer would be this one. But the least number of significant figures is this one, so the answer would be 19.0 meters raised to the power of 4. We also have some sort of review here. Take note that scientific notation is another way or convenient way of writing a very large numbers or a very small numbers using the powers of 10 notation. So it is expressed into this form where C is the characteristic digits. It's from 1 to 9. While M is the mantissa digit, it's from 0 to 9. While E is the exponent, it is the number of times the decimal is moved either towards left or right. So for example, positive ang exponent results when the decimal is moved from right to left direction. The number is greater than 1. So pasabot ka, it's a very large number. So for example, I have here 98,000, blah, blah, blah. So if I'm going to write this to scientific notation, here's the decimal point. So I'll move 1, 2, 3, 4. So you'll have 9.81 times 10 to the 4. Okay, nganong na 81, nganong na 1. The adjacent side of 0 is 6. Okay, next, rule number 2. Negative exponent results when the decimal is moved from left to right, meaning to say it's a very small number. For example, I have this here. So, ang scientific notation way of writing is 1, 2, 3, 4, 5, 6. So, 8.4 times 10 to the minus 6. That would be all. You can try this quick quiz. And thank you for watching. Don't forget to like and subscribe our YouTube channel. Once again, thank you and God bless.